So whenever you have negation of conditional, it always says it is negation of negation P and negation of Q. Q implies P becomes converse statement, not Q implies not P becomes contrapositive proposition or a statement. So when you are verifying any compound proposition, so if the last table contains all the values as true, it is nothing but tautology. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are revising the chapter Mathematical Logic. From the chapter Mathematical Logic, we are getting 1 mark question, 2 mark question and 5 marks question. So let's see the distribution of marks in each category. So from the chapter Mathematical Logic, you have from part A, that is 1 mark question, you will be having 1 question for 1 mark and 1 question for 2 mark in part B, and part D, that is containing 5 mark question in part D. So total you will be having 8 marks from this chapter. So let's see what are the type of question they may ask you for 1 mark, 2 mark and 5 mark question. So here we are at 1 mark question. Negate the proposition negation P condition Q. So whenever the condition is given, we are negating the statement negation of P condition Q. So whenever you have negation of conditional, it always says it is negation of negation P and negation of Q. So negation of P becomes, double negation of any proposition become P only. So this is equal to negation of Q. So that is P and negation Q. Next, negate the proposition 4 is an even integer or 7 is a prime number. So take 4 is an even integer as P and 7 is prime number as Q. So we have a negation P or Q. So whenever you are negating P or Q, that is equal to negation P and negation Q. So therefore here the statement changes to 4 is not an even integer. So because negation of P or Q is negation P and negation Q. So you have to negate the statement P. 4 is not an even integer. You should use the word and. 7 is not a prime number. So this is how we will negate the given statement. Next, write the inverse of the proposition. So inverse of the proposition. So here we have if x into x minus 2 is equal to 0, then x is equal to 2. So let me take x minus 2 is equal to 0 as statement P, and this is one more statement or proposition Q. So inverse is nothing but negation P implies negation Q. So therefore what does the statement becomes? If x into x minus 2 not equal to 0, then x is not equal to 2. So this is the inverse of the given proposition. Next, symbolize the proposition 2 plus 5 is equal to 6. So take 2 plus 5 is equal to 6 as one statement, that is P. Next, all integers are rational, take it as Q. What is the condition we have used? Here we have a OR. So therefore OR we symbolically write it like this. So this is how we symbolize the given proposition. Next, symbolize the proposition if oxygen is a gas, then gold is a compound. Take oxygen is a gas as P and take gold is a compound as Q. Since we are using if then condition here, it is implies statement. So therefore we symbolize the given proposition in the form of P implies Q. Next, 2 mark question. Write the converse and contrapositive of the proposition. Most of the year you will be writing the statement in the form of converse and contrapositive. So let's take here x square is equal to y square, then x is equal to y. Converse is, if you take this as P and this as Q, Converse is always Q implies P. So here what it happens, first we need to write on Q, if x is equal to y, then x square is equal to y square. Next, contrapositive is not Q implies not P. So therefore what I should write here, if x is not equal to y, then x square is not equal to y square. So this is how we can write. So Q implies P becomes converse statement, not Q implies not P becomes contrapositive proposition or a statement. Next, write the converse and contrapositive of the proposition. If the questions are easy, then the students score better marks. Let me take the questions are easy as statement P and students score better marks as Q. So we have a conditional statement in the form of P implies Q. Now converse is nothing but Q implies P. So therefore the statement becomes, if the students score better marks, then the questions are easy. Questions are easy. So this is converse of the given proposition. Next we will take contrapositive. So contrapositive is not Q implies not P. So let's write in the form of not Q. If the students do not score better marks, then the questions are not easy. Because we need to negate both the statements, so we have to write do not score better marks. Instead of easy, we should use not easy. Next, if P, Q and R are the proposition with the truth values F, T, F respectively, then find the truth value of the following compound proposition. So here we have P, Q and R. The truth values are given F, T, F. So we need to find out the compound proposition Q implies R and then P implies Q implies R. So first let us find Q implies R. What does implication says? If the first statement is true, second statement is false, we need to find out false. Next we need to write P implies Q implies R. So here we need to take the combination of these two columns now. So first one is false, second one is false, so therefore it becomes true. So therefore the given compound statement is true. Next, if negation P or Q or negation R is false, then find the truth values of P, Q and R. So here we have negation P or Q or negation R. When we say both statements are false, this is false when both are false. So here F implies F. So this implies what? Negation P on Q is false and negation R is false. Again, when this statement becomes false here, so this statement becomes false when both are false. This is equal to false. So therefore, here if negation R is false, then R is true. So from this condition we have negation P is false. This implies P is true. Next we have Q is false. Next we have R is true. So therefore the truth values of P, Q and R is true, false and true. So these are the truth values of the given statements. Next question. If the truth values of the propositions P, Q, R are T, T, F respectively, then find the truth values of the compound proposition P implies Q and R. So we have P, Q, R. and the values are given in the form of true, true, false. First, let me check Q and R. So, conjunction is true when both are true. In all the other cases, it is false. So, next we need to combine these two statements. P implies Q and R. So, implies is always whenever the first statement is true, second statement is false, then the answer is false. In all the other cases, it is true. So, we have in the form of true, false. So, therefore, the statement is false. So, therefore, the given compound proposition is a false proposition. So, these type of question, they will ask you for 1 mark and 2 mark question. So, let's see for 5 mark question. So, in 5 marks question, they will ask you to find out the logically equivalent or whether the given proposition is a tautology or a contradiction by the method of the truth table verification. So, here I have taken one question. Examine whether the propositions P and not Q or Q and P or Q are logically equivalent. So, for this, I have drawn a table here. So, first we will write the truth table for P and Q. So, let me write for P, true, true, false, false. For Q, I will write true, false, true, false. For the first statement here, I need negation of Q, then I should combine with P, then I should combine with Q. So, first let's write negation Q. Negation Q is false, true, false, true. Next, I have to combine P and not Q. When we say conjunction is true, when both statements are true. So, only in the second case it is true. In all the other cases, it is false. Next, I need to combine this statement with R, that is disjunction. When we say disjunction is false, when both the statements are false. So, here only in the last case we have it is false, in all the other cases it is true. Next, we will take P or Q. So, disjunction again. So, it is false when both are false. In all the other cases, it is true. So, see the column number here 1, 2, 3, 4, 5, 6. So, what I can write here? Column 5 and 6 are identical. Column 5 and 6 are identical. So, therefore, that means they are logically equivalent statement. So, therefore, I can write P and not Q or Q is logically equivalent to P or Q. So, after verifying through the truth table, you have to conclude the statement that they are logically equivalent. So, these type of questions carries 5 marks. Next question, verify whether the proposition is a tautology, contradiction or neither. So, whenever if you are verifying with the truth table, so when you are verifying any compound proposition, so if the last table contains all the values as true, it is nothing but tautology. If it contains all the values as false, it is contradiction. If it is a mixture of true and false truth values, then it is neither tautology nor contradiction. Now, let us verify the given compound proposition now. So, let's see here. Let's write the truth values of P, true, true, false, false. Q, true, false, true, false. Now, let's write negation Q. Negation of Q is here false, true, false, true. Next, I need to take P implies negation Q. P implies Q is false. When P is true, Q is false. In all the other cases, it is true. So, in the first case, I can write it is false. In the second case, third, fourth, I can write all the values as true. Now, let's take the negation of this statement. It is true, false, false, false. Next, so this part is completed. Let's take the next one, negation P biconditional Q. So, negation P is false, false, true, true. Biconditional with Q. So, biconditional says when the two proposition have same values, it is true. If it has different truth values, it is false. So, now let's check. So, for first one, it is false. For the second one, it is false. For the third one, it is false. and for the fourth one also it is false because they are all different truth values. So therefore it is F, 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 F. Now combine these two statements, that is OR. So OR says if both are false, it is false. In all the other cases, it is true. So therefore it is false, false, true, true. So here we have the mixture of truth values, true and false. So therefore, the given proposition, it is neither tautology nor contradiction. So when you verify the compound proposition, if all of them are F, it is contradiction. If all of them are T, it is tautology. Here it is neither tautology nor a contradiction. Next question. Prove that P disjunction Q combined with negation P and negation Q is a contradiction. So here I have written the values in the form of a truth table. So here we have PQ. So true, true, false, false, true, false, true, false. Now let's take OR. So when both are false, it is false. In all the other cases, it is true. Next we need negation P and negation Q. So for that, let's take negation P. False, false, true, true. Here it is false, true, false, true. And it's a conjunction. Conjunction is true when both the statements are true. So next we will take negation P and negation Q. It is true when both are true. In all the other cases, it is false. Now we will take conjunction of A and B. That is, if both are true, it is true. In all the other cases, it is false. We can't find two values true. So therefore, it is false for all. So clearly, the given compound proposition is a contradiction. Hence, conclude the statement, therefore, it is a contradiction. So therefore, 5 marks question will be in the form of a logically equivalence, proving tautology or contradiction, or finding the truth values of any compound proposition. So these type of question carries 5 marks in your examination. We'll meet you in the next session with a new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.